Seth Shostak. Welcome to the program.
Thanks very much, Russell.
Seth Shostak is the Senior Astronomer at the SETI Institute in Mountain View, California. Inspired by a book about the solar system he read at the age of 10, he began his career with a degree in physics from Princeton University and a PhD in astronomy from Caltech before working with radio telescopes in the U.S. and the Netherlands. He's hosted SETI's Big Picture Science podcast since 2002. In 2010, he was elected as a Fellow of the Committee for Skeptical Inquiry and is the chair of the International Academy of Astronautics SETI Permanent Study Group. He has published 4 books and nearly 300 popular articles on astronomy, technology, film, and television. To learn more about Seth Shostak, visit SETI.org. Seth, what is the SETI Institute and what kind of research is conducted there?
Well, the SETI Institute, Russell, is a nonprofit research organization. That's, sort of analogous to Woods Hole, Oceanographic Institute, whatever. There are lots of organizations that, from a legal point of view, are somewhat similar. And we began this institute more than 30 years ago as a place where we were doing what was in NASA SETI research. In other words, we were trying to find ET by doing what Jodie Foster did in the movie Contact, by listening for signals that would tell us somebody clever is out there. Since that time, the Institute has broadened its research programs. Today, most of the scientists here are doing what's called astrobiology, so they're interested in the questions of whether there is or ever was life on Mars. There are 5 moons of the outer solar system that might have life, could have life, certainly look habitable, and so they're researching those. And then general questions of the formation of important molecules in comets and asteroids that might have gotten life started here on Earth and other such matters. Anything with regard to the question of life in the universe, to be quite honest.
You said astrobiology. Is that a legitimate field of study, or is that a pseudoscience?
I don't think it's a pseudoscience any more than cancer research is pseudoscience. It's based on real data. Most of the people here use data from NASA spacecraft, either orbiters or rovers on Mars, but not only. The Cassini spacecraft zipping around the Saturnian system has learned a lot about this big moon Titan there. Titan actually has lakes on its surface, and those lakes are filled with hydrocarbons. They're filled with ethane, methane. They're lakes of liquid natural gas. They've been sitting there for 4 billion years. They may have cooked up something interesting. So there actually are a lot of data. We haven't found any life, but we found lots of places where there could be life, including, by the way, a lot of the people here work on the Kepler Space Telescope, NASA's Kepler Space Telescope, which, as you probably know, has found already 1,000 planets around other stars and 3,000 candidate planets that are still awaiting confirmation. It's found something like, 70 or 80% of all the planets we know in the cosmos so far. But more important than that, it's also found that probably something like 1 in 5 stars will have a planet where life could gain a foothold and maybe move on to bigger and better things. So it's not. I mean, to ask whether it's a science, well, then you better ask the people at the University of Arizona, the University of Washington, the University of Washington in St. Louis, and countless other places that have departments in astrobiology, whether they're really doing science. I think they would say yes.
When you say life, life can take many forms, and you're saying 1 in 5 stars have a planet that can support life, but how many are Earth-like planets that could support human-like life?
Well, if you're talking about complex life like humans, right, so that's big multicellular life, as opposed to the kind of life that dominated this planet for the first, 80% of its existence, more actually. That's just microbial life. You need a microscope to see it. There are undoubtedly far more worlds that could support microbes, but maybe not something that creeps, crawls, or flies. But nobody knows. But the fraction of those planets that are actually truly Earth-like in the sense that they have liquid oceans, thick atmospheres, and that sort of thing, we don't know. But it could be, close to 100%. More likely it's, something smaller than that. Even if it's only 10%, that still means there are billions of Earth-like worlds just in our galaxy.
So is it your personal belief that there is intelligent life, just as intelligent at least as humans out there?
Oh yeah, I wouldn't do this job otherwise. That's my personal feeling on the matter. Mind you, that doesn't count in science. It doesn't matter what I believe. What counts in science is, what have you measured? What can you do in terms of an experiment to confirm that your idea is actually a good one? So that's what it's about, and that's why we do the research.
If you're receiving messages from space, are you also transmitting them?
We do not transmit. And, of course, up until this point, we haven't received any either. That's what we're looking for. But we do not transmit. There are people who do want to transmit, and including some people even here at the Institute who find that an interesting idea. We don't have the equipment to transmit anything, but there are places in the world where they do, and people have done so in the past. I mean, there have been some fairly famous transmissions to the skies. Most of them are sort of in the nature of stunts. I don't think that they were very seriously intended to elicit responses. I mean, 2008, right? NASA sent a Beatles song to the North Star, Polaris. I don't think that they really were hoping that the Beatles would become popular on any planets around that star, but, it was just a kind of a demonstration of capability, if you will.
I have a question here from Dr. Astro. He's a forum moderator at GLP. Stephen Hawking has famously stated that if the great silence should be broken and we should detect a signal from an extraterrestrial intelligence, that we should wait until we have developed further as a civilization before answering back. He has suggested that currently meeting an advanced extraterrestrial race would probably go poorly for us. Could you please respond to that statement and give your thoughts on whether we should or shouldn't attempt to answer back?
Well, there actually is a protocol, although it doesn't have any force of law. It's just sort of a two-page statement of good ideas that says, indeed, if SETI were to find a signal, don't send anything back until you've had sort of international buy-in on what you should say or whether you should say it at all. I don't see any harm in that. The facts are, of course, that if we did pick up a signal, I'm sure that anybody with a backyard antenna and the ability to solder together a transmitter is going to be broadcasting their own philosophies to space. Look, you have to keep in mind that there's a big difference between sending messages via radio waves or even flashing lights into space and, somehow getting into an interstellar rocket and going there. I mean, I agree with Hawking that if the aliens were to come here, I personally would head for the hills, because if they have the technology to come here, it really doesn't matter what we do in terms of defense if they're aggressive, because they can completely overwhelm us. It's Bambi meets Godzilla, and we're Bambi. But on the other hand, that's not what we're talking about. We're talking about broadcasting messages to societies that could be many hundreds of light years distant, and to bridge those distances is quite a hard thing to do.
How would we know that the signal is extraterrestrial?
Yeah, that's a good question, because we pick up signals all the time. We pick up signals, I don't know, when I watch the screens, something like every 10 seconds you get a signal. So how do you know, is that ET or not? And what we do is we just had some very simple tests that allow us to compare the signal from some small spot on the sky where we're looking, where, there's some star system, with another small spot on the sky that's fairly close but not exactly the same. And if it's interference, if it's just a telecommunications satellite that's producing a radio signal that you pick up, you'll find it essentially everywhere in the sky because it'll be so strong. But if you don't, then you can say, wait a minute, this looks like a signal coming from that small spot on the sky. And that's the kind of thing you're looking for. And if it moves across the sky at the same rate that the stars do, and they move, of course, because of the spin of the Earth, well, then you know that this signal is moving with the stars. And that's not a satellite. That's got to be what you're looking for. So that's what we look for.
Wouldn't the vast distances of space distort ET signals?
Well, obviously signals weaken with distance, but I mean we knew that 500 years ago. It's the same with starlight, right? Starlight is just there's no difference between light and radio waves, just the frequency, just the color, if you will. And your eyes, which have an aperture of maybe a quarter inch or something like that, they have no difficulty seeing a star, that might be hundreds or maybe even 1,000 light years away. You just go out at night and you can see a star. Okay. Well, the same with the radio waves. If you have a big enough antenna, you can pick up signals from as far away as you like. I mean, a lot of this depends on how much money the extraterrestrials might be spending on their transmitting projects, and of course we have no way of knowing that. But yeah, they get weaker, but so does light. I mean, that's just the geometry of space. But it doesn't mean that you can't pick up something very far away, because indeed we pick up radio signals coming from distant galaxies. When I say distant, they're billions of light years away. So you can do it if the signal's strong enough and you got a big enough antenna.
But if it's billions of light years away, that signal was sent a long time ago, billions of years ago.
Yeah, absolutely. But in the case of, studying galaxies, that's okay. You don't care. In fact, that's actually a good thing because it allows you to examine the history of the universe because you're looking back in time. If you're talking about SETI, we're not looking at anything billions of light years away. We're looking at the nearest star systems. So they're typically, 10 light years away, 100 light years away, in a few cases maybe 500 light years away. So yeah, those signals will be, 10 years old or 100 years old or maybe 500 years old. But so what? I mean, I read, Julius Caesar when I was in high school, and that signal was 2,000 years old. It was still interesting. Yes,
but at the point that they sent the signal, they have now evolved that much more.
Well, but so what? I mean, it's like saying that, hey, I got a letter from my aunt today, and, it took the Postal Service 3 days to get it to me, so, my aunt isn't quite the same as when she wrote the letter. That's true. But, of course, I don't know anymore, if all I can get is letters. I don't know anything more about my aunt, and the real point was not that. The real point is that it proves my aunt is out there, or was out there 3 days ago. So that's the thing you're trying to learn. The fact that the aliens may have, moved on to something else, yeah, I presume that they did. But what you're trying to show is that there's somebody out there.
Now, if you were to find a signal, what would be the protocol? Would you call the White House? What do you do?
Well, yeah, that sounds like the Hollywood version. Actually, the protocol itself simply says that if you find a signal, the first thing you do is you check it out very thoroughly because, you don't want to make a big news story and then it turns out, oh, well, it was just something wrong with the equipment or, who knows. So that's point one in the protocol, which only has 3 points, by the way. Point two is that you tell everybody, and point three is that you don't broadcast back without, first getting international buy-in. We discussed that one. But in reality, we've, gotten occasionally false alarms that for a while look like they're the real deal, so we know what really happens. And what really happens short-circuits all the protocols, because what really happens is that immediately the media are on top of the story and they're calling us up. So that's what will actually happen. You'll be reading about it in the press long before we've even, confirmed this to our own satisfaction, that we're even sure ourselves that this is truly ET. So you'll probably read about it in the checkout line at the supermarket first.
Well, what's the biggest false alarm you've had? Have you been woken up in the middle of the night and had to run down to the SETI Institute? Well, I did have that, but it wasn't quite the middle of the night. It was like 7 o'clock at night. It was after dinner, and I got a call from the boss here, and he said, you better come on down here. And there was a signal, and for most of the day, it looked like the real deal. Now, this was back quite a while now. This was 1997. That was the last time we got a signal that looked so good for so long. It eventually turned out to be the SOHO satellite, which is a European solar research satellite, the signal of which was bouncing around the steelwork of our antenna, just the right way to spoof the kind of thing we're looking for. But it was very interesting to have this false alarm because, we thought, well, this might be it. And, of course, what's occurring, the public figures, oh, well, the federal government will shut you down or stuff like that. That's all conspiracy theory gobbledygook. In fact, the government didn't show any interest at all. What did happen is that the New York Times began to call us up. That is what happened. So I'm sure that was a very good analog for what would happen if we picked up a real signal, that the media will be all over it within 12 or 24 hours. So the government isn't really up your ass about this whole SETI thing, excuse my language. No, I wish they were. Give us some funding. Yeah, no, they seem to have no interest. So who does fund SETI? It's the SETI research here at the SETI Institute is all privately funded. It's just people, very often these will be technology types who think, we finally have enough science and enough engineering capability to build instruments that might tell us if somebody's there. And it would be kind of a shame not to at least try. Another question from the audience. How do we explain that with all the computing power available and the chunks of data to process through, SETI at home over the past 15-plus years, how is it that we don't have any signal at all?
Yeah, well, it's true. SETI at home, that's not our project, by the way. That's a project of the group at the University of California at Berkeley, which is, I don't know, about 50 miles away from where I'm sitting. They indeed use people's home computers to process some of their data. It's actually a small fraction of their data. And that allows them to, well, it's the biggest computer in the world by some measure. So that allows them to process the data in ways that normally they wouldn't be able to do. That's a good thing to do. It's an excellent thing. But the fact that we haven't found anything so far doesn't, I don't think that has any real significance because, for example, we look at individual star systems. How many have we looked at? Maybe a few thousand. Well, the galaxy has a few 100 billion star systems. So to say, well, you haven't found anything, I guess they're not there, that's kind of nutty because unless you have a reasonably sized sample, you shouldn't expect to find anything, even if extraterrestrial intelligence is quite prevalent. So I'm optimistic because the speed of the search keeps improving. The technology keeps getting better. And I think that in the next 20, 25 years, there's really a good chance we'll find something, but we'll just have to see.
Another question from the audience. Wouldn't it be better to focus SETI data on a specific spot, say Orion Nebula, to search multiple spectrums in that one area, or maybe use the resources to locate and record the signals from the object in orbit found by STS-88?
Well, I don't know what the latter are, and I don't think I would spend a whole lot of time looking at the Orion Nebula either, to be honest. We do look at individual spots on the sky. The Orion Nebula is very young. I mean, it's a nebula that's forming stars. These stars haven't had enough time to cook up probably not even life, let alone intelligent life. So that sounds to me like precisely the wrong place to look. Same with, there's a lot of stuff in the literature, Zeta Reticuli. People call me up all the time. They say, why aren't you aiming your telescopes at Zeta Reticuli? And this is, Betty and Barney Hill stuff. Well, it turns out we actually did look at some of the stars in Zeta Reticuli. It's part of a bigger program, but and we didn't hear anything. But Zeta Reticuli, again, it's a very young star. That's not what you want to look at. If you really think that intelligent creatures, intelligent species take a while to evolve, and after all, they took, 4 billion years on Earth to evolve, then, you want to look at older stars. So those are not great targets.
Another question from the audience here. When a single electron, a charged particle, is accelerated the minimum amount to create EM radiation, how many out of the 3 dimensions does the EM radiation propagate in?
If I knew the answer to that, I'd probably be in Stockholm collecting a prize. I mean, we know how it behaves in, if you will, classical electrodynamics. We know how that works. Classical electromagnetism, 3 dimensions of space, 1 dimension of time. If you're asking how does that, the radiation from an electron manifests itself in, the 10 dimensions of string theory, to begin with, that begs the question of whether string theory is correct, and secondly, which of the gazillion string theories is the right one to describe the cosmos. So honestly, I have no answer to that one.
Well, the audience member goes on to say, so now, if there are alien spacecraft or planets in our galaxy, which we must assume there are, and they are emitting signals via EM radiation, you see my question poses the angle and density of signal emitted from the source, and how it propagates and travels over space, and how this relates to us on Earth. Go ahead.
Well, I was going to say, I don't understand any of that, because, to say, look, maybe it's radiating in other dimensions. Well, maybe it is. I mean, maybe there's a party going on in my office here in the 10th, 11th, and 12th dimensions, but I have no way of measuring any of that. I don't know any physics that allows me to build equipment that would allow me to see that party. So, there's not much I can do about it. But what we do know about, transmissions and so forth, is what we know, the physics we do know. And there we can build some equipment. We can build very sensitive radio receivers and so forth. And we can just go on the assumption that, well, maybe they're using this kind of technology, and we can find evidence for them. I mean, you could sit on your hands for a long time saying there are, hyperdimensional physics, or there's some sort of physics we don't know that is the way the real aliens communicate. Yeah, but having said that, that's all you can do, because if you don't know the physics, you can't design an experiment. So it's kind of a very short discussion, if you will.
Well, what frequency are you listening on? And if you had more funding, would you be able to create devices that would listen on more frequencies?
Yeah, absolutely. And in fact, we did get a grant from a gentleman down in Southern California who is funding the construction of new receivers for our Allen telescope array. That's the equipment we use. That allows it to monitor frequencies between about 1 gigahertz and 12 gigahertz, roughly speaking. And, that's more than a 10-to-1 range of frequencies. So that's quite a range. That's much more than any previous SETI experiments have ever done. So, yeah, indeed. And we typically listen to 60 million, that's 60 million channels simultaneously. So, we cover as much of the radio dial as we can because obviously we don't know where on the dial ET might be broadcasting.
How long has SETI been in operation for now?
Well, the discipline of SETI, that began, at least in its modern form. I mean, there were people who wanted to do things even around the time of the American Civil War, but, they were looking for Martians or inhabitants of the moon. That wouldn't have worked for obvious reasons. But modern SETI, using radio technology, dates back to 1960, when a fellow by the name of Frank Drake did an experiment in West Virginia for a couple of weeks. Frank Drake actually has an office down the hall from here, and he still comes into the office actually on occasion. So he's still busy with it. But the SETI Institute, which is the organization where I work now, that was actually founded in 1984. So that's a little over 30 years ago.
Has the enthusiasm for SETI waned? It's been a long time, and you still haven't found anything.
Well, I mean, I don't know. Certainly not, not for me, but, for the general public, are they less interested than they were? I think that's kind of hard for me to tell. We still get quite a bit of interest from the public, from the media. I give, talks quite often about SETI. And so, and there are articles and this, that, and the other. So, from my point of view, the interest is still there. And I think you could argue actually that the interest in SETI may have actually increased recently because what has happened in the past 20 years in astronomy that's really interesting, maybe the most interesting thing in astronomy, well, I don't know, you could argue this, but I think one of the most interesting things in astronomy is the discovery of exoplanets, the discovery of planets around other stars. 21 years ago, if you asked an astronomer, do you think there are planets around other stars? They would say, well, it seems reasonable. I would expect them, but, we hadn't found them. And now we find that, essentially all stars have planets, or certainly the majority of them have planets. That's a big discovery, and I think that gives a certain impetus to SETI, which it may have increased the interest, because Mr. and Mrs. Front Porch out there, they're not paying that much attention to developments in science, but they certainly know that we continue to find planets. And, they also may pay attention to the fact that we continue to find history of Mars, for example, that suggests it may once have had life. And they put two and two together in their minds, and they realize, this may not be the only world with life.
How rare do you think humanoid life is? Because personally, I think it's 100% exclusive to Earth. If you were to change only a few parameters, such as the gravity or the orbit, humans would maybe not exist at all, or certainly would look different in some way. This Star Trek visualization of the universe, to me, is a bit absurd. But how do you think the universe teems with life?
Yeah, well, look, it is true that if you were to change some of the basic parameters of physics, the gravitational constant you just named, then you wouldn't have stars, planets, not us. That's true. But the facts are, that's a well-known problem in cosmology, and one of the possible solutions to that is something called, parallel or multiple universes. Maybe that's the answer to that. But in any case, forget that. It's the facts are that our entire cosmos, all we can see, 100 billion galaxies, each with a few 100 billion stars and a few 1,000 billion planets, they all have the same laws of physics. So to say that, we're special, we're unique, humanoids are special and unique, you can't argue that it has anything to do with the laws of physics, because we know the laws of physics are the same everywhere. Go to the other side of the galaxy, go to the Andromeda galaxy, the laws of physics, the laws of chemistry, they're all the same. They're the same. So if this is the only place where there's intelligent life, then Earth is a miracle. It's a miracle. and I have to tell you that in science, miracles don't have a terrific track record.
All I'm saying is that not to adjust the principles of physics, but the gravity of Earth is 9.81 meters per second squared. If it were 10 meters per second squared, life on Earth would be something different.
Not very different.
Well, it would be different, though, to some degree.
Yeah. No, it wouldn't be that different. If we had grown up on Mars, Mars really does have a different surface gravity. Sure, we'd look a little different. And I'm not saying that the aliens look like us. I don't expect them to look like us, actually. In the movies, they do, right? And if you see a movie where flying saucers land and the aliens step out, these little gray guys, they look pretty much like us, except they have less hair, right? But, I don't expect that. I mean, you go to the local zoo, they don't look very much like you either, and they've grown up under the exact same circumstances you have. And they share most of their DNA with you, too, and they still don't look like you. They don't necessarily look like us. I'm not saying that. But what I'm saying is that changing the gravity by, a few percent, 10%, 20%, even 50% doesn't rule out life. I don't see how that can rule out life.
Another audience question here, and there's a comment afterwards. Don't you think an advanced civilization would use a quantum principle for instantaneous communications? Or do you think they would still use light-speed radio waves to communicate across light years? Let's see his bullshit. Yeah. And I got to let you know what he says here. He goes, let's see his bullshit answer on this one. If he admitted the truth, that would put an end to SETI as it is right now, and he would be out of a job. It's ridiculous to think that a super advanced civilization would use radio waves or anything that is limited to light speed. Comment.
I get that email twice a week. I tell you. And it
maybe
usually
it's the same guy.
Right, yeah, it could be, although I doubt it. He signs it differently every time. I think it, and I particularly like the part that, they would shut down SETI right away if this truth were revealed. I mean, it's like, got to keep this from the boss. If he only heard this, we would shut everything down. I mean, that's bizarre beyond actually. I mean, I have a hard time, understanding somebody who has that kind of mindset. But let me say this. Look, if there's a way to send information instantaneously to beat the speed of light, then they're probably using it. The only thing is, we've never found anything like that. Yes, there's quantum entanglement. That's the other email I get several times a week. Why aren't you using quantum entanglement? It's instantaneous. Well, it's not. If you're a physicist, you know that it's not. Einstein said you can't send information faster than the speed of light. And as far as we can tell, every experiment we've done, and that includes quantum entanglement, by the way, it proves that that's true. You can't send actual information faster than the speed of light. Yes, you can examine the spin of an electron here. Its twin on the other side of the universe will instantly have its spin determined. But that's not sending information. You can't send bits. You can't send messages that way. So, the physics we have says there's no way to send information faster than the speed of light, so the speed of light is the way to do it. Now, is that to say that maybe there's physics we don't have that would allow you to do that? Well, maybe. I mean, it would be hubris as the first water to suggest that, the physics we don't know might not allow that. But at this point, physics simply does not allow that. So you can sit around and speculate on this, but that would be like Chris Columbus saying, I'm not going to build the wooden ships, I'm going to wait for the jet aircraft. You can do that. But if you really want to discover America, you use the wooden ship.
In simple terms, how does your equipment work, and what makes it unique?
Well, our equipment, essentially, it's a bunch of antennas. We have 42 antennas. It's called the Allen Telescope Array, as I mentioned, and they're in Northern California, about 300 miles north of San Francisco, in the Cascade Mountains. There, it kind of shields them from all the radio interference in the Bay Area here. And we point them in the direction of nearby star systems that we think are the right kind to have an old planet around them that might be like the Earth. That turns out to be a lot of them these days, but we didn't do that when we started. We point them in those directions, and then we look at as many frequencies as we can, looking for very narrow band signals that are at one spot on the radio dial. Those are the kinds of signals that transmitters make, but things like pulsars, quasars, hot gas, cold gas, all of which make radio waves, don't. So that's how we know, okay, this is somebody at the other end with a transmitter. So that's what we do. We just systematically go through as many star systems as we can. Now, the technology of how it works, that's, I don't want to talk about that because that's just engineering, if you will. And although it's very interesting and a bit complex, it's straightforward radio engineering.
This is kind of a ridiculous question, but a lot of people have mentioned it, so I'm just going to ask it. Are you a paid government shill paid to suppress the public knowledge of extraterrestrial life?
Yeah, well, that is kind of a ridiculous question. I mean, gosh. I mean, if that were true, then they owe me back pay. That's my first reaction to that. And I've been accused of that many times, actually, usually in email. But once at a talk I was giving in San Diego, some guy stood up and he said, you're just a mouthpiece for NASA. And I said, God, I'm on the NASA payroll. It's news to me. It'll make my wife happy, too, to hear that I have a second source of income. No. Look, if nothing would increase our funding faster than any really credible evidence that there were, that there were aliens, put it that way. And that's also, by the way, true of NASA. People love to beat up on NASA, that NASA's hiding evidence of, alien encampments on Mars, or that some rock, looks like a chipmunk and must be, something left over from some other biota. NASA's budget would quadruple overnight if that were true. So the idea that we would keep this kind of thing quiet is, the conspiratorial mindset, and, I see a lot of that, so I can, in a sense, understand it, but it's certainly not true.
Do you think the government has too little a priority in searching for extraterrestrial life?
Well, I mean, you could always do more with more money. But if you look at the funding for this sort of stuff, I mean, how much do we spend? We spend all the big bucks looking for life by sending rockets to other parts of the solar system. That's where the big money goes. NASA, but not just NASA, the European Space Agency, the Japanese Space Agency. I mean, there are all sorts of, if you will, government initiatives to try and find evidence that Mars once had life or, still has life, or moons of Jupiter or moons of Saturn, 5 of which are very promising in terms of the possibility of life. Now, what would happen if they could double their budgets? Well, they could do it all faster, that's for sure. And they could also do other things. For example, build a telescope, which has actually been designed, that would allow you to measure the light coming off of planets around other stars and look for things like oxygen or methane, things that would tell you, hey, there's some sort of, photosynthesis or some other plant metabolism down there. So that's another way to find life. Essentially no government money goes to SETI, none. So, obviously I would think it would be better to spend a little bit of money doing SETI, but that's my personal point of view. So, yeah, sure. If you consider this something worth knowing, if you spend money faster, you might get to the answer faster.
Have you heard of the Disclosure Project?
Yeah. No, I certainly have. I mean, there's Steve Bassett and there's Stephen Greer, and all these guys are, they like to maintain that the government has information that would prove the existence of aliens nearby or here or whatever, and they're just covering it up. I don't buy into that myself, because I think if the aliens really were here, it wouldn't just be the U.S. government that would know that. Every government in the world would know that, unless the aliens only like to visit America. And, I don't know their preferences. Maybe they like our food better. I have no idea. But, the idea that all governments of the world are covering this up just strains my credulity. That's what's called an argument from ignorance. In other words, there's good evidence, but I can't show it to you because it's being covered up. Well, you're never going to convince scientists of anything with that kind of an argument, because they're going to say, look, if you can't show me the evidence, then you're just telling me stories.
That's a good point. What do you think NASA's true motive is? Because I can't imagine that the government throws money away at anything for just altruistic reasons. Are they looking to mine other planets?
Oh, NASA's the government agency that everybody loves to hate. I mean, they love it and they hate it at the same time. I feel sorry, because I know a lot of people work at NASA. The NASA Ames Research Center is, 2 miles away from where I'm sitting here, and a lot of our scientists actually prefer to work over there because it's a better library or they need labs or whatever. And you go around and you talk to these guys, you know, NASA has an ulterior motive. They're only doing the space program because they want to mine all these planets or these moons or asteroids or something like that. And they look like you just, you know, pop down from Mars or something if you say that, because, of course, they're the ones doing the work. And they know none of that is true, that, you know, NASA is like the Postal Service. Do they have an ulterior motive? You know, well, they're just trying to deliver the mail, actually. But, you know, in the case of the NASA scientists, those are all individuals, and there are tens of thousands of them. And they've all, you know, gone to school, gotten degrees, you know, so that they can do research because they're curious about what's really true in the universe. And that's what they're trying to find out. And the government has a history since the Second World War, anyhow, of paying for a little bit of that research. It's called basic research. And, you know, taxpayers get all exercised about whether they should be doing that or not. I think that basic research always pays off in the long term. But it's not about mining the moon or the Mars or anything like that. But there are private firms that might be interested in that. In fact, there are private firms that are interested in that. But, you know, not basic research. That's about knowing things. That's about learning things.
Here's kind of a nice question, just a physics question from the audience. If the Big Bang Theory is correct, what did it explode into? What surrounded the nucleus before the blast?
Yeah, well, it might pay for people who have that question, because it's a very natural question to have, for them to read some books on cosmology, and then they'll come across the fact that this idea that you have, that there was this big, empty, dark space, this big, empty room, if you will, and the Big Bang goes off somewhere in there, bing, and then suddenly blows out the material that forms atoms eventually, and then, you know, stars, planets, and us, is wrong. That's not the way it is. There's no universe. There's no empty room. The Big Bang creates space. So there's no space around it to go into. It's creating space. That's one of the products of the Big Bang. It's making space, and it's making it, you know, all the time, and that's why the galaxies recede from us. It's not that the galaxies are moving away from us. It's that space is getting bigger. That's what's actually happening. So that's just a matter of, you know, it might pay to read a book on cosmology.
Another question here from the audience. Sounds like something from Star Trek. What is a Dyson sphere?
Yeah, Freeman Dyson, a famous physicist. He's still active, actually. He's a very, very clever guy, extremely bright guy. And what he said was, look, you know, we've got energy problems. Maybe the Klingons have energy problems. So what's the ultimate solution there? You know, you can burn oil, you can have windmills, you can do all that. But, you know, in the long term, what you can do is you can say, look, the sun is putting out, what is it, 10 to the 26, and we use 10 to the 14, so that the sun is putting out trillions of times more energy than we need for everything we do on Earth. And it's all just wasted. It just goes off into space as light, right? So a really advanced society would do something like, well, what we could do, take apart Neptune or Pluto or something that's not very useful to you. Just take it apart and rebuild it as a big, you know, a big shell around the sun, but, you know, outside the orbit of Earth, of course. And so it doesn't block sunlight to the Earth. But it does collect all the rest of that sunlight with photocells, and then you beam as much of that energy as you want back to Earth on microwaves. All of that is technically possible. It's a very big project. We're not going to do it. But maybe somebody else has done it. And so they may have built these sort of swarms of solar cell satellites that orbit their star. And it's called a Dyson swarm or Dyson sphere. And, you know, actually there have been some attempts to try and find these around other stars. It turns out to be hard to do. But, you know, it makes sense. I mean, that's one way to get all the energy you need for your gusto-grabbing lifestyle.
Do you ever think we'll find extraterrestrials in our lifetime?
Yeah, I do. I've in fact bet most people a cup of Starbucks that we'll do that within 24 years.
In 24 years? Well, I'll bet you a coffee on that one.
Okay.
How far can we listen?
Well, there's no limit. I mean, it depends on how big their transmitters are, as I pointed out. I mean, you know, one of the big experiments being done in physics and astronomy, for that matter, for the past, well, I don't know, like 30, 40, 50 years now, is to measure what's called the microwave background. That is the leftover glow from the Big Bang. Well, that's a radio signal. And, you know, the guys down in Antarctica who have specialized equipment looking for that for various reasons having to do with cosmology. But they're picking up signals that are coming from 13 billion light years away. There's no limit to how far back, how far away you can look if the signal is strong enough and you have an adequate receiving setup.
How many people work at SETI, and how could one get a job over there?
Yeah, well, if you want to do astrobiology, we ask that you get a grant so that you have your own money. We don't have the money to pay you, but if you find the money to pay you, we'd be happy to put you to work here. In the SETI group, which I run, the SETI group is very small. It's like 5 people, something like that, and it's run on donations. So money is a big problem for us. The number of people that work at the SETI Institute these days is about 130, 140. But as I say, the number of people who do SETI, that is looking for intelligent life, is more like 5.
And I know you've written some books. Where can the audience pick those up and learn more about you, Seth?
Well, I would suggest, obviously, they should go to the SETI Institute website, SETI.org, really easy to find. We have our weekly radio show, which doesn't just talk about SETI, it's about science in general, big picture science. But the other thing is, if they're interested in the books, my most recent trade book is called Confessions of an Alien Hunter, and they can just search the web for that.
We were talking before the show. You have a skeptics segment in your podcast once a month. My last question of the day is, what is the biggest misconception that people have out there about science?
Well, there are so many, but I think the ones, a lot of it, for example, UFOs, I don't think we're being visited. You can argue whatever you want, but I don't see that as quite the same issue as, for example, the belief that some people have that autism is caused by vaccination. We're seeing the effects of that kind of misinformation now because, there are people getting measles or their kids are getting measles and they don't need to. And worse than that, it's going to kill some of them. And so, that's a misconception about science that has real-world consequences, mostly in medicine. There are a lot of people who doubt, for example, Darwinian evolution. Well, that turns out to kill people, too. Not directly. It's indirectly. It turns out in terms of the medical care that they might refuse to have, that kind of thing. So, in terms of effects on people, I suppose I would say that this idea that evolution is just an idea and it's not proven by science, that I think has the biggest consequences. There are many, many other things. We could, Bigfoot and all these things. And, did we really go to the moon? There are people who think we didn't, that kind of thing. Most of that is just, well, okay, that kind of thing. But there are some aspects of our misunderstanding of science that have real consequences. And perhaps the greatest of these is that compared to Europe, and I lived in Europe for quite a while, compared to Europe, Americans are very skeptical about science, which I think is going to hurt the country in the long term.
Seth Shostak, it's been an honor to have you on the program. Thank you so much for being a guest today.
My pleasure, Russell.